This is an example video for implicit differentiation, tangent lines, and normal lines. These are a little bit different examples from what I went through in my other videos. So here are the two examples I'm going to go through. So in this first example, so it says find 2 points where x squared minus xy plus y squared equals 5 crosses the x-axis. Are the tangent lines at these points parallel? So this is one question. And then the other one, find any normal lines to the curve 2xy plus 4x plus y equals 0 that are parallel to y equals 1/4 x plus 2. All right, so find 2 points where x squared minus xy plus y squared equals 5 crosses the x-axis. Are the tangent lines at these points parallel? So this actually is a lot of work in one very small question. So first things first, it says find where this crosses the x-axis. So for where this will cross the x-axis, you might want like a little just visual of that. So here's a graph, and just here's a random graph crossing the x-axis. So think about this point here. This point right here, it doesn't even matter what it is. The big thing about this is that the y coordinate is 0. So for me to figure out where this crosses the x-axis, I need to plug in 0 for y and then see if I can solve. So let's do that. So I've got x squared minus x times 0 plus 0 squared equals 5. And so thankfully this is not too difficult to figure out then, right? So this will just be x equals plus or minus the square root of 5, and we can just leave it like that for now. So these are the 2 points then where the graph will cross the x-axis. So we'll say square root of 5 comma 0 and the negative square root of 5 comma 0. Okay, so now we want to figure out, are the tangent lines at these points parallel? So I've got 2 different points. I've got the word tangent in here, which means that I'm going to have to take the derivative of this. So I have to implicitly differentiate. So this will be 2x minus, so I have to use the product rule on this part right here. So this will be minus, so let's see, let me put a square bracket here. So this is 1 times y, there's the first part of the derivative. And then for the other part of the derivative, this is x times 1 dy dx, and then plus 2y dy dx, all of that equals 0. Okay, so now I can distribute this minus sign into this set of square parentheses. So I get 2x minus y minus x dy dx plus 2y dy dx equals 0. So now I need to solve for dy dx. So I will leave these 2 pieces on this side, and I'm going to bring these 2 pieces over to the other side, and I'm also going to factor out dy dx. So with dy dx, so factoring it out of this term and this term, that'll leave me with negative x plus 2y. And then bringing these 2 terms over, I just need to flip their signs. So this negative y will become positive y on the other side, and then this is minus 2x. So then I can finish solving for this. So I've got dy dx equals y minus 2x over negative x plus 2y. Whew. Okay, so now we can actually answer the question here, which is, are the tangent lines at these points parallel? So what makes 2 lines parallel? 2 lines are parallel if they have the same slope. So 2 lines are parallel if the same slope. So this is a formula that helps me determine the slope at a particular point. So I have to determine the slope at each one of these points, and if they are the same, then they are parallel. So let's clear just a little bit of space here. And so let's see, we have dy dx. So now I'm going to plug in, you know what, let's start with, we'll start with the first point. So if I plug in the first point, I get y minus 2 times the square, oops, sorry, I totally missed it. Okay, so I need to plug the square root of 5 in for x and 0 in for y. So where I see y, I'm now going to replace it with 0, so this becomes 0 times negative square root of 2 times square root of 5. I cannot write. It's almost my dinner time. And then this will be negative square root of 5 plus 2 times 0. So if I simplify all of this, I get negative 2 square root of 5 over the negative square root of 5. And so those just all cancel out, so I just get actually 2 as my slope here. So that was the first point. So now let's plug in the second point. So now I get dy dx. So once again, I'm going to plug in 0 for y and then negative square root of 5 in for x. So this becomes 0 minus 2 times the negative square root of 5 over negative square root of 5 plus 2 times 0. So I get dy dx equals 2 times the square root of 5 over the square root of 5, and that all equals 2, which, hey, I get the same slope for each. So yes, the tangent lines at these points will be parallel. We don't have to go any farther. We're not being asked what the tangent line is, right? We just want to know, are they parallel? Slopes are the same. Now this problem here is a pretty tricky problem. So find any normal lines to the curve 2xy plus 4x plus y equals 0 that are parallel to y equals 1/4 x plus 2. So for this particular problem, we're talking about normal lines. Normal lines and tangent lines kind of go hand in hand, so we know we're going to take a derivative of this. So let's go ahead and take the derivative of this thing. So remember, you're going to have to use the product rule here. So this is going to be 2y plus 2x dy dx plus 4 plus 1 dy dx equals 0. So if I factor out dy dx, this will leave me with 2x plus 1. And then the things that don't have dy dx, so that's 2y and 4, I'll bring those over to the other side. So I'm going to switch their signs. This becomes negative 2y minus 4. So the derivative here is going to be negative 2y minus 4 over 2x plus 1. Okay, so we have the equation to figure out the slopes of our tangent line. So what do we do with this? Well, now in reading this information, so remember, what we need is we're looking to get some normal lines, and you can't figure out a normal line or a line if you don't have a point and a slope. Now, I do have a slope here, right? I have 1/4, but I don't have a point. So part of the problem here is going to be figuring out what the point is. And this is the equation for the slope of a tangent, right? And this is my normal slope. So I actually need to figure out what would be the tangent line in this situation. So if my normal line is going to be parallel to this, which means that my normal line has to have a slope of 1/4 to be parallel, then my tangent line is going to have a slope equal to -4 because that's the opposite reciprocal. So what does this have to do with this? This needs to equal -4. That's ultimately what I have to figure out, is how can I choose some points to make this equal -4. Now, you might be thinking, oh, I'll just start plugging in some points and trying to find something that works. But this actually, that's not very precise. That's not going to get us what we need. We can't just start randomly plugging in points. These points have to work in this situation here as well as our original curve at the same time. And this is good, actually. This means that we have a system. And so I already have one equation in terms of x and y. This other equation is in terms of x and y. So from here, we're just going to kind of play with this and see if we can find some way to relate this equation to this equation. So let me clear some space. And let's go through the motions of trying to solve for one of these variables. So I'm going to have -2y minus 4 equals -4 times 2x plus 1. So then I get -2y minus 4 equals -8x minus 4. And now looking at this, which letter looks easier to solve for? I would say y. So if I add 4 to each side, the 4's will drop out. So I'm left with -2y equals -8x. Divide each side by -2, you get y equals 4x. Okay, so we got y equals 4x. This has to do with just my tangent line. And I haven't used this equation yet, but what's great about this is now I have this equation. I can substitute this into this, and now I've got kind of the two situations playing off of one another. So that's kind of what you want to have happen when you have a system. So I've got 2x. So now where I had this y, I'm now going to replace it with the 4x, So that's 2xy is now 2x times 4x, because 4x comes from down here, plus 4x plus 4x equals 0. So let's just work this out. So I get 8x squared plus 8x equals 0. And hey, I can totally solve this. This becomes 8x times x plus 1 equals 0. So I get x equals 0 or x equals -1. So these will be the 2 points then that if you plug these in, these are the points that will get us that slope of -4. So we still have to figure out what the y coordinate is here. So I can take these, I can plug them either into this or into this equation here, or I could plug them into this, right? Just whatever was in your system. So I'm actually going to use this form of the equation right here just because it's the easiest one. So if I plug in 0, I will get that y equals 0. So one point is 0, 0. And then the other point will be, so if I plug in -1, this will be -4. So the other point where this occurs will be -1, -4. Okay, so now I have the points and I have the slope that I need for my normal line. So now let's just kind of back up here. Let me clear some space. So this part right here, this was the derivative, or the really the equation for the slope of the tangent line. And we set this equal to -4. This is what we wanted our tangent line, the slope of our tangent line, to be. And then we found, by kind of playing this off of this equation up here, we found that these 2 points will be true in both equations at the same time. So these are the 2 points where the tangent line will have a slope of -4. And now I can move on to finding my normal line. So if my tangent line has a slope of -4, then the normal line will have a slope of +1/4. And now I've got my slope and I've got my point. And now I can do this twice. So I can use my point slope form here. And I basically just plug these points in. So I can plug in 0. And so the equation of one normal line will be y equals 1/4 x. And then for the other one, so now I can do y plus 4 equals 1/4 times x plus 1. So I have y plus 4 equals 1/4 x plus 1/4. So this will be y equals 1/4 plus, or minus 15/4. So here are the normal lines for that situation. So like I said, this was definitely a tricky problem. So if you have to watch it over a couple of times, that would be expected. Okay, so that'll cover it for this video. Thanks for watching, guys. I'll see you next time.